Hello, guys. How are you? I hope you are doing good. So, let's begin. So, today we will discuss about some of the ways through which we come to know that there is an exoplanet at all. Transit photometry. Scientists have detected the most number of exoplanets through the transit photometry method. In the year 2014 alone, over 800 alien worlds were detected through this method. The idea is that you observe the brightness of a star continuously. If a planet passes in front of the star, the amount of light received from the star dips or is reduced for the duration of the planets. The amount of the dip is very minute. The Earth-sized planet transiting a star like Sun would provide a 0.08% dip in brightness to any observers. By the observer, the frequency of the dips and the amount by which the light dips, researchers can figure out various characteristics of the planet, such as its orbit and size. The rays of the light emitting from the host star also passes through the atmosphere of the planets. Before reaching Earth, spectrography analysis of this light can indicate the composition of the atmospheres of the exoplanet. The method requires the planet to come in between the host stars and the astronomical instrument. The chances of this happening are actually very minute. So the next one is Doppler spectrography. The approach is known as radial velocity method or the wobble method. After transit photometry, this is the method used to confirm the existence of the most number of exoplanets. While transit photometry is more common used now, in the first few years of the exoplanet discoveries, it was primarily thought Doppler spectrography that planets were identified at all. About 30% of all known exoplanets have been discovered through this method. All planets cause side disturbance to the host stars because of their masses, essentially the star wobble. Astronomers use extremely sensitive spectrograph can measure the wobbling of the star through tiny red shifts and blue shifts. By measuring these shifts accurately, researchers can locate planets and even identify their mass. Doppler spectrography is most common used to identify gas giants, particularly in close orbits around the host stars. Gravitational microlensing. The gravitational microlensing has been used to discover only about 19 planets so far, but the number can potentially go up in the future. Discovering planets through the microlensing requires a precise alignment of two stars. As seen from the Earth, the light from the background star is bent around the foreground star. The light interacts with any planet in the system of the foreground star as well. If the foreground star has a planet, the light from the background star is slightly brighter. Unlike the other detection methods, gravitational macrolensing is good for finding planets that are particularly well with stars that are towards the center of the Milky Way galaxy. As it is more likely that two stars will align in that direction, there is a narrow window of opportunity for discovering exoplanets through the gravitational macrolensing method. The lensing event lasts only for a few days or weeks and doesn't repeat again. Other disadvantage of this method is that exoplanets are typically so far away that there cannot be follow-up observations through other instruments. Large networks of autonomous telescopes are put to this task of surveying portions of the sky to observe lensing events in the hopes of finding an exoplanet. So the next one is transit timing variation. Transit timing variation is a method of detecting additional planet in a system with an already identified transiting planet. If you remember, this is when a planet comes between the host star and an instrument on Earth. In systems with a number of planets, there is a gravitational interaction between the planets. Planets stuck at each other's orbit, accelerating or deaccelerating them in their journeys around the host star. This means that planets do not transit with the same periodicity as seen on the Earth. By timing the periodicity, additional planet can be detected. The transit timing variation method for detecting exoplanet is a relatively recent development. With the first such detection through the Kepler spacecraft in 2011, the method is particularly useful for systems with multiple planets in orbital resonance or lockstep. In such systems, each of the planets interact with the others, gravitationally keeping them in space, even though they are incredibly closer together. TRAPPIST-1 is such a system with 7 planets in orbit closer to the host stars than Mercury is to the Sun. Transit timing variation was used to estimate the masses of the planet as well as their orbital characteristics. And the last one is direct imaging. Less than 20 planets have been directly imaged. This is because the planets are typically so close to the host star that they are lost in the glare from the star. The planet needs to be at significant distance from the host star and as a gas giant much larger than Jupiter for it to be directly imaged. Directly imaged planets are typically gas giants, brown dwarf, or could even be dim stellar companions. Another category of objects that are good for direct imaging are young worlds active in the infrared spectrum. Direct imaging works only for the star closest to the Earth. Thanks for watching the video. Please like and subscribe.